Circle the precipitate that forms in each of these double replacement reactions. So it's important to note that precipitates are always insoluble based on the solubility rules, and it's always going to be a product. So I'm only looking at the right side of the arrow, not at the reactants. Now, to determine whether or not it's insoluble, we have to use the solubility rules. So first we're going to look for the chloride ions, and that's right here. And chloride is soluble unless, and here are the exceptions, unless it is matched with silver, lead 2, or mercury. And notice that lead is our cation. So lead chloride is going to be the opposite of soluble. It's going to be insoluble. So because this is insoluble, that is going to be the precipitate between these two. Notice NO3 nitrate is here, and that is soluble with no exceptions. So this is definitely soluble. You can also label precipitates as S for solid and things that are soluble as AQ for aqueous because it can be dissolved in water. Now let's look here at chloride with potassium in front. And we'll notice that chlorides are soluble and potassium is not an exception. So this is soluble, so I'll put a little AQ afterwards. And then CO3, that's carbonate, and carbonate is down here. Carbonates are insoluble, and calcium is not an exception because calcium is not ammonium, and calcium is not an alkali metal, it's an alkaline earth metal. So calcium is not an exception, therefore this is my precipitate, and I will label it as a solid. Finally, I'll check here at phosphate, PO4, and phosphate is here. It is insoluble, and ammonium is an exception. So instead of being insoluble, it's actually soluble. So this, I'll put an AQ, is soluble. And then here, SO4, sulfate with rubidium. Sulfate is soluble, and rubidium is not an exception. So this is also soluble. And in this case, because both of them are soluble, it means no precipitate formed, which is a possibility. And that's how you determine the precipitate in a double replacement reaction.